Hello, my name is Steve Bowler, and in this video I'm going to be configuring OSPF. In particular, within OSPF we're going to be taking a look at OSPF external route summarization. We're going to be taking a look at how to configure route summarization externally, and also we're going to be taking a look at the differences between internal and external route summarization. On one of my previous labs I went through and configured internal route summarization. And what we remember with OSPF, with internal route summarization, is that it is done on the ABR, or the otherwise known as the area border router. However, what we're going to see here with external route summarization within OSPF is that it is performed on the autonomous system boundary router, or the ASBR. And we're also going to see that the configuration set for OSPF external route summarization is also different. So as you can see here in this lab, we have four routers: router 1, 2, 3, and 4. We have areas 12, 0, and 34. So area 12 connects router 1 to router 2. Area 0 is connecting router 2 to router 3 via fast Ethernet, and then area 34 is connecting router 3 to router 4 via their serial 00 links. Again, router 1 to 2 is serial 00 as well, and that's going to connect router 1 to 2. So if we remember with OSPF internal route summarization, that is performed on the ABR. So in this case, the ABR would be router 2 and router 3, because router 2 connects area 12 to area 0, and then router 3 would be an ABR because it connects area 34 to area 0. But what we're going to find here with OSPF external route summarization is that what we're going to do in this example, at least, is we're going to configure router 1 and router 4 to be the ASBRs, and we're going to be injecting into our OSPF domain, we're going to be injecting external routes. And we're going to do this by using loopback interfaces on both router 1 and 4. And we're just going to do redistribution from the connected interfaces into OSPF. So I'm going to walk you through this whole process, and then the last but not least item that we're going to hit on this lab is, of course, the whole reason for the lab, which is OSPF external route summarization. So we're going to be performing OSPF external route summarization on router 1 and 4 because we're going to make them the autonomous system boundary routers. And then we're going to go through, we're going to configure all of the routers. We're going to do show commands to verify the correct operation of everything that's going on. So let's go ahead and get into router 1 and get it configured. Again, it's just got its serial 00 interface. We'll give it the IP address 172.16.12.1. Let's go ahead and do a no shut there. Then we'll go into the OSPF process here. We'll go ahead and advertise its directly connected interface serial 00 into OSPF process. So that's 172.16.12.1. We'll go ahead and put it in area 12. And for now, that should be... Actually, let's go ahead and put on here our loopbacks. We'll just create like a loopback 0, which is going to be 10.0.0.0/24. Then we'll have loopback 1, 10.0.1.0/24, and loopback 2, 10.0.2.0/24, and loopback 3, which is going to be 10.0.3.0/24. So what we're going to do with these loopbacks, we're going to advertise them into our OSPF domain. And actually, we're not going to advertise them with a network statement. We're going to bring them in through redistribution. That way they come into the OSPF routing process as external. And then what we're going to do, that'll make router 1 an autonomous system boundary router at that point. And then what we're going to do is we're going to go ahead and configure summarization on router 1. And that should be it. Let's go ahead and move this topology down a little bit. So what we're going to do here on router 4, we'll bring in a couple networks from router 4 here. We'll do the 192, or we could do the loopback 0. Let's just do the 40 network. So we have loopback 5 here, which is going to be that should be good for now. So as you can see here on router 4, we have 2 networks, 2/24s, and then on router 1 we have 4/24s. So we're going to be performing route summarization, external OSPF external route summarization on router 1 and 4. Alright, so we have router 1 partially configured. Let's go ahead and get it all the way configured here. Let's go into the loopbacks, give them IP addresses here. Okay, so router 1 is all configured now, at least for the time being. We're gonna still have to perform redistribution. We'll go back and do that in a minute here. Let's go to router 2. Let's go ahead and get it configured here. So let's go ahead and get the serial interface back to router 1 configured. So we'll do 172.16. I'm sorry, not 172. 172. Yeah, that's right. 172.16.12.2. Do a no shuts, and then we'll go ahead and configure the fast Ethernet here while we are configuring the interfaces. We'll configure the fast Ethernet interface to router 3. It's going to be 172.16.23.2. And then we'll go ahead into OSPF process 1. We'll go ahead and do network, and then 172.16. We could just leave it as 172.16.00, then do a Class B subnet mask, 255, but let's go ahead and be specific as possible here. It's always better to do that. So 172.16.12.2. So this is just going to advertise our with a host mask here. This is just going to advertise in just this specific IP. Whatever interface is running this IP, it's going to be advertising into OSPF. So we'll put this 172.16.12.2 into area 12. Actually, before, what I was saying about putting in the Class B, the /16, that wouldn't work in this case because we have 2 different areas here. So if we have a network statement 172.16.00 with 255.255.00, We do that in area. We have to choose an area, so we wouldn't be able to add that whole class B into, you know, two different areas basically. So in this case, 172.16.12.2 0.0.0.0 is going to be put into area 12, and then we're going to put in 172.16.23.2, and we're going to advertise that into area 0. That's going to be backbone. And then as you can see, we have a neighbor adjacency change within OSPF. If we do a show IP OSPF neighbor on router 2, we can see that we see router 1 as a neighbor. Neighbor ID here is router 1. And everything looks good on router 2 now. Let's go to router 3, get it configured. First thing we'll go do the fast Ethernet that's going to router 2, 172.16.23.3. Could do a no shut here, and then we'll go into serial 00, which is going to router 4. We'll give that the IP address 172.16.34.3. The /24 subnet mask, we'll go ahead and do a no shut, bring up the interface. Then we'll go into OSPF process 1. And we'll go ahead and get our network statements here to advertise our interfaces into OSPF. So 172.16.23.3 is going to be the network going to router 2, which is in area 0. And then we'll do 172.16.23. I'm sorry. Yeah. 34.3. That's going to be going to router 4, and we'll put that in area 34. Alright, so if we do a show IP interface brief on router 3, for some reason I did not. Let's see if I can ping router 2 here. Unable to ping router 2. Let's go ahead and go into router 4. Let's get it configured, and then we'll go back and make sure we have full reachability. So we'll go into interface serial 00. We'll do a 172.16.34.4. Again, /24. We'll do a no shut. And we'll go ahead and create our other loopback 0 interface and our loopback 5 interface. So we'll do IP address of 40.0.0.1 /24. Then we'll go ahead and create our loopback 5. Give it the IP address of 40.0.0. 40.0.5.1, and that's going to be /24. Then we'll go into OSPF here, process 1. We'll advertise our directly connected interface into OSPF, so network 172.16.34.4. And then that's going to go into area 34. And then as you can see, we have our neighbor adjacency has come up. So if I can do a show IP OSPF neighbor on router 4, you see that we have a neighbor relationship formed with router 3. So now it looks like if I go into router 3, problem is we're not seeing router 2 as a neighbor. So let's go ahead and just do a quick troubleshooting session here on this. Shouldn't take but a minute. Show IP protocols. Okay. 23.3 is in area 0. Let's verify that's the correct IP on the interface. Yes. So it should be sending hellos out to router 2. Make sure we have... Let's go back to router 2. If I do a show IP interface brief on router 2, looks like it has the correct IP address too. Let's do a show IP protocol on router 2. And it looks like let's do this. Let's do clear IP OSPF process. Alright, so it looks like we have a problem here. Router 2 and router 3 are unable to form an adjacency. Okay, so let's figure this out, guys. Why is this not coming up here? Between router 2 and 3, we are not able to perform an adjacency. Let's just do router 3. Can we ping? See, we can't even ping the other side, and I don't know why that is. We should be able to ping from router 2 to router 3. I'm going to stop the video here just for 1 second, or I mean pause it, and then I'm going to bring it on once I've figured out what happened, and I'll let you guys know. Okay, well, it looks like I found the problem. I had the wrong interface configured on router 2. Router 2 is using Fast Ethernet 01 to connect to router 3, whereas router 3 is using Fast Ethernet 00 to connect to router 2. So router 3 is configured correctly with the Fast Ethernet 00, however router 2 is not configured correctly. So let's go back to router 2. Then we can also do this command. It's pretty cool from global config if we want to default an interface here. You know, set the interface back to its default configuration. The command is just default space interface and then just put in the interface. So Fast Ethernet 00. In our case here, alright, give that a second to run. Now it looks like it's good. So if we do a do show run interface Fast Ethernet 00 now, should have no configuration there. So let's go ahead under Fast Ethernet 01 on router 2. We'll do IP address 172.16.23.2. Go ahead and do a no shut, bring the interface up, and we should see the neighbor adjacency come up here momentarily. And there we have it. All at once, once the line protocol layer 2 came up, boom, layer 3 came up right after that. So we had layer 1 come up, layer 2, and then layer 3. So we're good to go now all the way through our routing domain. I should be able to, on router 1, if I do a show IP route, you can see now I have my inter-area routes here. You know, 23 is between router 2 and 3. That is an area 0 network, and then the other inter-area route is the 34 network, and that's between router 3 and 4, and that's in area 34. So let's go ahead and ping 172.16.34.4. That would be router 4's serial 00 interface. just to make sure, and we do have connectivity. So let's go ahead now and get our not redistribution. Let's go ahead and take a look at the OSPF external route summarization. We'll start with router 1, and what we're going to do on router 1 is we're going to be taking its 10 networks, the 0, 1, 2, and 3 networks, and we're going to redistribute them into OSPF. And that way they come into the OSPF domain as external type 2 routes. And then we'll be able to configure external summarization on router 1. So we're going to make router 1 here the ASBR. Again, within OSPF external route summarization, it can only be performed on the autonomous system boundary router. So that's why we are going to bring these routes in as external on router 1. So let's go ahead and do that real fast. Real simple way to do it. The quickest way to do it was go under the OSPF process and just do a redistribute connected. And then don't forget the keyword subnets. So if we forget the subnets keyword here, these networks will not come into the OSPF process because they are, Class A networks. However, the subnet keyword allows, classless, and it allows the subnet mask to be advertised in. So let's go ahead and do that. So to verify that these subnets are being seen all throughout the network, we could just go to like router 4 all the way across the other side of the network now. And if I do a show IP route on router 4, now we can see the 10 networks, the 0, 1, 2, and 3, coming in as OSPF external type 2. So let's go into router 1. If I do a show IP protocols now on router 1, you can see here under routing protocol OSPF 1, you can see now we have the statement that this router is an autonomous system boundary router. So whenever you get a task that says, hey, you need to perform external OSPF external route summarization, the fastest way to verify that you're on the correct router for external route summarization is to just do a show IP protocols command, and then you'll see the process say, yes, we are indeed an autonomous system boundary router. So if we go to router 4 and do a show IP protocols, you can see that it does not have this statement within its configuration here. If we go to router 2 and do this show IP protocols, what you can see, like I was telling you guys earlier, is that router 2 is an area border router and router 3 is also an area border router. So now that we have these routes coming in and they are being seen throughout the OSPF routing domain, what we can do on router 1 to summarize these routes and to shrink the size of our routing table and to save on CPU resources and bandwidth within the network, what we could do is we can go ahead and perform route summarization on router 1. We'll take these 4 networks, and as you can see, they go in and they will give us a, they'll give us a /22 network we can advertise these as. So let's go ahead and perform OSPF external route summarization. Let's go under router OSPF 1 on router 1, and we'll do the command I don't know why I was thinking it was IP in front of there. I think that's with EIGRP or RIP or both. Don't quote me there, but one of the other routing protocols has the IP command in front of it. So we'll do here, we'll just do a summary address command, as you can see, to configure IP address summaries within OSPF. So we'll do summary address, and then we'll configure our summarization, which is 10.0.0.0. Then it's going to ask us for our subnet mask. Again, we're doing a /22 here, which is this mask here, 252 in the third octet. Then we have some other advanced features within OSPF we're not going to get into right now. However, you can set the tag. It means you can tag this summary route. You can also do a not advertise, so you won't be advertising this network when you are translating OSPF type 7 LSA. So we're not going to worry about that. That has to do with, not so stubby areas, which is an area type within OSPF. So we're not going to deal with that right now. Let's just get to basic external route summarization. So we'll go ahead and do a summary address command here, and we'll go ahead and hit enter. Then we'll go to router 4. We'll do a show IP route. And now what you can see here is you can see that we have the /22 that's being advertised throughout the routing domain. Instead of the 4 routes in our routing table for the individual /24 subnets, we're actually now seeing just the one /22 network. And just to verify we still have reachability, let's just ping to one of the networks here, and as you can see we have reachability. So that is it. That is how to configure basic OSPF external route summarization. Let's go on to router 4 and do the same thing. So on router 4 here, we have the 40.0 network and then the 45 network. We're going to go ahead and advertise those into OSPF with the most specific subnet mask as possible. Again, we're going to bring them into OSPF as external by doing a simple redistribute connected subnets command. We'll verify these subnets are being injected into the routing domain. If we just go to router 1, we do a show IP route. As you can see, the 40 network is coming in as external type 2. Go ahead and try to ping that. And as you can see here, we have reachability. So what we'll do now is we will go into router 4. Now that I have done the redistribute connected subnets command on router 4, if I do a show IP protocol, now you can see that this router is an autonomous system boundary router. So we just made router 4 as well in ASBR. And again, the ASBR is the only place you can perform OSPF external route summarization on. So let's go back to router 4 here, and we will try to summarize these two networks with the most specific mask as possible. So we'll go to router OSPF 1, and we will do a summary address command. Follow that up with the network we're trying to summarize, which is the 40.0.0.0, and then in this case what we're going to do is the 255.255.248.0, because we have 8 networks with this /21 here. We have 8 networks in which we're going to be able to summarize. That would be 0, 1, 2, 3, 4, 5, 6, and 7. Again, if you don't know how to subnet, you might want to take a look at that before you get into trying to summarize within OSPF and other routing protocols. It's very important to learn subnetting and have it down cold, especially after I mean, even for the CCNA, you need to know how to subnet pretty well. But you need to be able to just look at these networks and just be able to know how to summarize it, what the subnet mask is going to be right off the bat. Basically, you want to be able to subnet in your sleep. Once you got that down, you're good to go. So in this case here, we're going to do a summary address 40.0.0.0, and then we're going to give it a /21 summary. And what we can do, I'll just throw on a tag here for you. Tag is going to be 4.110, and this tag is going to be representative of 4 is going to be router 4, and then 110 is the administrative distance of OSPF. So we'll just play around with the tag here, see if we can see it within the routing domain. So now that I've configured the summary address on router 4, let's go throughout the routing domain and see if we can see this. Actually, let's do this real fast. We'll do the no command there. Let's go to router 1, show IP route. We'll do a clear IP route. Okay, let's see. Let's go ahead and do a debug IP OSPF events. Also do a debug IP OSPF let's see, debug IP OSPF rib. So now if I do a show IP route on router 1, we're still seeing the /21. That's what we want to see, but let's do this real fast. Show run pipe to begin OSPF. What I wanted to show you here is in real time, these updates coming in, from router 4 all the way through the routing domain to router 1. Okay. That's our problem there. When we did the no redistribute connected subnets tag and then 4.110, it just took off the tag. So let's go here and do router 1, or I'm sorry, router OSPF 1. We'll go ahead and do a, well, wait a second. No, it shouldn't. I'm sorry. I don't know what I'm saying. On router 4, when we did the summary, see how the summary is still on here? I don't know why I was talking about the redistribute connected. Never mind what I said earlier about the redistribute connected. The summary address is still showing up here. That's because when I did the no summary address, it just took off the tag and not the rest of the summary. So let's go back into router 4. We'll do a router OSPF 1. And we'll do a no summary address. So let's go ahead on router see, now we can see some of these networks coming in. Okay, on router 1, let's just do a debug IP routing as well here. We're going to get a lot of stuff here, but let's go into router 4, and now let's put that summary on and see if we can see anything. Wow, maybe a little too much information here. Okay, so on router 1, once we put in the summary on router 4, what we can see here is that let's see here, we are now receiving in the OSPF rib, we are receiving the summary address, which is the 40.0.0.0 with the /21 subnet mask. So a lot of stuff here happening in the background within the router that you don't see unless you turn on some debug commands. But very good information to know. Also, you can see that it's deleting now from the routing, the routing table. It's deleting the more specific network, the 40.0.5. If we take a look into router 1 now, if we do a show IP route, you can see that we only have one external network, whereas before we had two external type 2 networks, which was the 40.0.0.0 network and the 40.0.5.0 network. However, when we created this summary, when we performed summarization on router 4, which is the autonomous system boundary router for these 40 networks, what we saw on router 1 is we saw that it is now receiving this summary route, which is the /21. So if I try to go ahead and try to ping to the more specific route here, which would be the 5 network, now you can see that we are successful. Also, if we do a show IP route, so as you can see here, we still have connectivity to the more specific route, even though we're only seeing the /21, we're not seeing the 5 network. However, that's encompassed within the /21 summarization here. Also, if I did a show IP route on router 1 for the more specific route, which is the 40.0.5.0 network, you can see here before where we put in the route tag, you can see now that the tag is being propagated through the routing domain, the OSPF routing domain, and being sent to router 1. I tried to see if I could find that within the debug command that we did up here, and I can't see that tag coming in. I don't think I did the correct debug command, but anyway, the point is here that the summarization, external summarization, again, let's go ahead and go back to the key points here. We looked at OSPF external route summarization. The key points are that it is performed on the autonomous system boundary router, and what we did to simulate routes coming in as external is we just redistributed connected on router 1 and 4, and that brought in the loopbacks into the OSPF routing domain as external type 2s. Then what we did was we went under the process, the OSPF process. So on router 4, if we do a do show run pipe to begin OSPF, we went under the OSPF process on the router, and we did the summary address command with our network and our subnet mask. And then we went ahead and we verified that we were seeing both on router 1 and 4 each other's summary addresses. So on router 1 we saw router 4's summary for the 40 networks, and then on router 4 we saw router 1's, again on router 4 here, we saw router 1's summary, the /20, I'm sorry, not /20, the /22 here for the 4 networks up here, the 4/24s that were advertised on router 1. Again, we had reachability on both routers, and we're able to ping to the more specific networks. So again, that's pretty much it. What we saw on router 1 and 4 is that we saw that any of the more specific routes, on router 1 and 4, we saw that they were suppressed. So in this case, router 4 only saw the 10.0.0.0 network /22, so it only saw that, and all the more specific routes were suppressed. Again, on router 1, when we did a show IP route, we saw only the 40.0.0.0 network coming in as a /21. So the more specific route, which was the 5 network /24, was being suppressed. So I hope you guys have enjoyed this video, and I hope you'll be with me with the next one. Thanks.